Okay, so today we have the integral of e to the root x dx, and this question tells me firstly make a substitution and then use integration by parts to evaluate. Okay, now firstly we all know that if we had it in this form, then that becomes so easy. It's just e to the x and plus c, of course. But because of that root x, we can't really do that. Okay, there's much more to be done. So in other words, the root x is our problem. And we know with our problem areas, we say, well, let them equal to, well, in this case, I'm not going to say u because it's going to get confusing with the integration by parts. So I'm going to use k, and you can use any variable, okay? So I'm going to say let k equal to root x, okay? Then dk, then dk is going to be 1 over 2 root x. Okay, if we take the derivative of this, it becomes this. And then because we are taking the derivative with respect to k, put a dx. Okay. Now solving for dx, we get that dx is 2 root x dk. And what I did was just multiply both sides by 2 root x. Now you might be thinking, well, if we're going to sub in k and we still have a root x, that's going to be our problem. Well, you might be right, but remember that k is root x. So what does that mean for us? That means that, well, dx is just going to be 2k dk. Okay. Now we are ready to sub in. So this integral is now going to be equal to the integral e to the k, and then our dx is this whole thing. Okay, cool. Now, as far as this goes, we can't really simplify much more. We could take out the 2 to the front of the integral, but I think I'm just going to leave it there for now. That's not going to make a big difference or help me in any way. So now we apply the integration by parts. And what does integration by parts say? Well, it says if I have any integral of u dv, then this is going to be u times v minus the integral of v du. Now, you might be thinking, what the hell does this even mean? Well, let's try and make this a whole lot easier. So, we're going to have u, and we're going to have dv, and we're going to have to pick one part of our integral to be u and the rest of it to be dv. Now, how would I pick u and how would I pick dv? Well, the rule of thumb to pick u is that if we take the derivative to find du, well, we still have to find du, okay? So we have to take the derivative. If we take the derivative, then I want that to reduce the power, okay? Now, if we look at e to the k, if we take the derivative of e to the k, it's just going to be e to the k. So it's not really reducing anything. But if we let u be 2k, and we take the derivative with respect to u, then this is just going to be 2 dk. So we did reduce the power. This k is gone now because we took the derivative. Now, because we chose u as 2k, then that means the rest of the integral, which is this and this, that's going to be dv. So this is going to be e to the k dk. Now we are almost done. We are almost ready. The last thing we need to find is v. Okay. How would we find v? Well, we have dv. So if you want to go backwards, just take the integral. So if you take the integral, that means that v is just going to be e to the k. And then we don't really have to put the plus c, because this whole thing is just like work on the side, basically. Okay, that's why we didn't say let, because we're not letting them equal. We're just basically like dummy variables. Okay, so now we have the integral of u dv. So u dv, and as you can see, they match up here. Okay, well, the order does not really matter, so we could change it because it does look a bit weird. So this is going to be e to the k 2k. Okay, now our formula says u times v, so u is 2k, v is e to the k, minus the integral of v du, and du is 2dk. Okay, now this is going to be equal to 2k e to the k minus, we can pull this 2 out so that we get the integral of e to the k dk, and then we know that the integral of e to the k or e to the x is just going to be the same thing. Okay, and finally what we could do is sub in back our k, which was root x, so 2 root x e to the root x minus 2 e to the root x. What I would do is, well, you can see that there's a common factor of this. Okay, can you see it? There's one here, and then there's one, oops, not that, this and this. So if we pull out that common factor, we get, oops, that's not going to be that, it's just going to be root x minus 1. And we are done, so we can add our plus c. And, well, finally, we could just conclude that, well, the integral of e to the root x dx is equal to 2 e to the root x into root x minus 1 plus c. And, oops, this is our final answer. And if you need the whole solution, this is the whole solution.